Okay, so we're going to move on to kind of continuing to work through chapter 40. Should be able to finish it here. So we talked about renewable and non-renewable sources of energy, fossil fuels, and then some of the renewable sources of energy that are being used around the world today. Um, you must, especially coming up to that election back in, God, when was it? February. You must have heard kind of a lot of calls that we're not doing enough in Ireland. We need to do more for development of our renewable energy resources, because like, we're doing okay, but we're definitely not meeting any of the targets that have been set. We're below on pretty much all of our targets. And we're not alone in that. Like, we just, generally speaking, have a lot more to do. So I suppose the first part of this is about why. Why is it so bad? Why is it so urgent? Um, so what are our current and future energy requirements? So I think everybody knows that we're an energy hungry society. I am literally sitting here with my laptop charging, so that's plugged in. My phone is charging. Horrific, but the telly is on and on mute. Like my toaster is plugged in over there, and the switch isn't off. It's on standby. Things like that. Like, we're just, generally speaking, very, very energy hungry, and the more developed the country, the more energy hungry it is. So the picture, that's a picture taken from, I think it's from the International Space Station, of, I suppose, most of Europe. You can see there, and you can just see the amount of lights. I mean, things like that, lights, like, it is not like, it's probably 2 generations ago that they still didn't have electricity. My father-in-law, so they're from kind of rural County Mayo, and he was quite sick as a baby, and I suppose in that, I mean, he's 70. I mean, he's not incredible, like, it's not like he's 104. He's 70, and when he was when he was born, he had a problem with his legs, and he needed therapy on his legs, so that, because otherwise he wouldn't have been able to walk. And basically, what that meant in those days, if you were from rural County Mayo and you had a farm to run, was that he was left in Crumlin Hospital for 2.5 years. So they come up to visit him, but like, they would have visited him once every 3 or 4 months when somebody could get away. Like, so he was basically on his own for 2 years in Crumlin Hospital getting his legs fixed. And he has this memory that when he did go home, he remembers getting into bed and he was trying to read it. I don't know, he was trying to play with his toys or something, and he was like nearly 3, and he has this memory of asking his mum to put the light on, and she was like, "What are you talking about?" And because in County Mayo they didn't have electricity, but in Crumlin Hospital in Dublin they did, so he was kind of familiar with flicking the light switch and turning it on, but they didn't have that. So that will give you a concept of how, for a short time, how far we've come in terms of energy, because they didn't even have lights in Mayo, 68 years ago. But anyway, we are putting more and more demands on energy, and we're doing it incredibly quickly. So at the moment, most of our energy is either fossil fuels or nuclear energy. We'll talk a bit about nuclear energy later. And the numbers are here. So these two energy sources supply 93% of the world's energy needs, and the remaining 7% at the moment is coming from renewable energy sources. So, like, it's massively skewed in favour of fossil fuels. Just looking at the energy demands here, as I said there, when they become more developed, the demand for energy increases quite dramatically and quite exponentially. Like I said, the difference in Ireland in a matter of 68 years. I mean, parts of the rural West Coast are definitely still behind more developed parts, even of Ireland. There's a massive push on at the moment to try and get broadband, because they just don't. I think the broadband, when you go down to Mayo, is probably where we were in Dublin, like, I mean, even 15 years ago, like, it's incredibly slow, like, so yeah, like, I mean, they're still sort of behind where we are, but there are there's more. I mean, that's the push. There's a massive push on there to get, like, broadband down to where that, pushing more and more and more energy demands. So the more developed a country becomes, the more demand there is on energy. Like, talk about the amount of cars in the road. I mean, even during this COVID-19 pandemic, I don't know if any of you've seen the pictures coming out of different parts of the world and the reduction in pollution over China, over Italy. There's fish in Venice again, things like that. Like the difference in taking the cars off the road. So there are over 1 billion cars on the road. Um, so again, there's energy needs there. That need to put petrol in those cars. Obviously, there's a push to go electric, but we're nowhere near there that everybody's using electric cars. As well as that, like the population is expanding, so it's expected that we're going to reach 10 billion people in 50 years' time. But I put this in because I thought this is quite stark. Energy experts expect that by the time we reach 2030, so it's 2020 now. I mean, even think back to 2010, it doesn't feel like that long ago. So 2030, another 10 years, the world energy demands will have increased by 55% compared to today. That is a massive increase. If you look over here, fossil fuels of the world now, electrical supply, 58.7%. And this is to produce their electrical demands. Nuclear 17.6, hydro is 13.9, geothermal, wind, solar and other is 9.8. There's the ECD data. So, like I said, there's targets. What's it called? Agenda 2030, I think is what the document is called, which is released by the powers that be in Europe to basically give everybody their targets that they have to meet in terms of their renewable energy, in terms of reduction of fossil fuels. So that's why there's a big push to electric cars. I know Toyota in particular are not making diesel cars anymore. They're gone. They literally are not making a diesel cars. They're only making petrol cars and they're making electric cars. And then there's a big push, like especially if you don't do a lot of traveling, like people within Dublin, my commute every day is like 10 kilometers or something. So, it's not like I do big miles. So for me to drive an electric car would make sense. It's actually more rural parts of Ireland that are struggling with the electric car because they're struggling to trust it when they might drive 200 kilometers a day. Anyway, so there is, I suppose, there's a push for electric cars, but we can only use the electric cars if the infrastructure is there. So there needs to be more charging ports. There needs to be more availability. These things called fast chargers. So I suppose from your phone, like when you put your phone on charge and it's not fast charging, like it seems to take an eternity. It's the same thing with the car. If you can't find a fast charger for your car, it could take like something like 26 hours to charge your car fully. Whereas with a fast charger, you can do it in 3. So things like that. So like there's a big push in saying that people need to drive more electric cars, but there's also a push on the government to make sure that the infrastructure is there so that if you were driving an electric car, you have a means of charging it. Anyway, so the fossil fuels, they have estimated it's going to run out, say, within the next 100 years. So we'll be in big trouble if our population has grown massively. More countries have become more developed and we've more of a demand on, we said in the next 10 years that the demand is going to increase by 55%. So what the hell's the story going to be in 100 years? We need to make sure that we have different forms of renewable energy in place. So the European goal is to reduce greenhouse gas emissions by 80 to 95% by 2050. And then obviously Ireland being in the EU has to fall in line with that. So yeah, our dependency on fossil fuels, as I said, they're running out. We can't continue to depend on them. We have to find alternatives. So many governments, along with trying to reach the targets for using renewable energy sources, are also looking to other forms of energy, and one of those forms of energy is nuclear power. Okay, so we're going to talk about nuclear power, not in massive detail. So nuclear power has huge advantages, incredibly high energy output, and they actually don't release greenhouse gases, so they don't release carbon dioxide. The chemical reactions that take place don't release carbon dioxide, so they're not contributing to global warming in that way. Obviously, if we could use nuclear energy, you're not depending on fossil fuels, and it's kind of with the high energy output, the same thing. It's very efficient in its production of energy. I mean, that's why we have nuclear power stations. Now, I'm sure you're all aware of why there is a negative with nuclear power stations. The big thing, well, there's probably two big things. One would be like safety. So there were two that I can think of. I think there's a third one somewhere in the US, but Chernobyl in the Ukraine. Um, I think that was in 1989, so it would be before your time, but I'm sure you've heard of it. And if not, Google it. It's horrific. I mean, even today, if you go back in, there's loads of videos out there. People gone back in with Geiger Muller tubes. So Geiger Muller tubes are Geiger counters. They measure radioactivity, and oh my god, the click rate on them is insane. Like even today, however many years on that is. Um, and then there was one. I can't. Was it 2011? Oh, I'm totally guessing. I'm not sure. But Fukushima in Japan. So that, like, you should remember that one. Um, so there are accidents that happen, and like at any industrial kind of setup, like they happen. But I suppose in one, maybe you lose a load of produce, and God help a worker loses an arm. Something that would be a horrific accident. But when it's a nuclear power plant, you're talking about leaking radiation out into the natural environment, and the effects of that are catastrophic. And most of the nuclear components that they use in these reactors have, they're called half-lives. They have incredibly long half-lives, which means they disintegrate really, really, really slowly. And so it's hundreds of thousands of years before the radioactivity is gone. And then how dangerous is radioactivity? If you're close when the radiation leaks, I mean, you're dead. And even the people who are miles away, a lot of people in Chernobyl, I mean, either died of cancer like 15, 20 years after what happened, or when they had children, their children had massive deformities, which was caused by their exposure to radiation. So, like, yes, it's just an accident at somebody's place of work, but the effects of it are catastrophic. The other problem, which is equally as huge, although it doesn't seem so dramatic, is they use fuel rods in these nuclear reactors, and the fuel rods are radioactive, and like I said, they take a very, very, very long time to disintegrate, and they're storing these fuel rods, so they have like containers buried under the ground, like lead containers buried under the ground. But like, it's going to be a problem for someone someday. Like, I don't know, they just keep putting spent fuel rods in there. They also have to transport those fuel rods, so they're still radioactive when they're transporting them, and that's a logistical nightmare. And then literally storing them. I mean, you can't continue to do this and to store them. You can't continue to store them indefinitely, I suppose. So while it's not a fossil fuel, it's still causing problems, and there's still going to be a point where you can't keep putting fuel rods into the ground. It kind of comes under the same heading of the problem with the materials, but the material that they use for these nuclear reactors is uranium, and uranium has to be mined, and the mining of uranium causes lung cancer. So the people who are mining it are, it's a death sentence, which is horrific. And here, even the nuclear reactor itself, they have a lifespan, so they have a lifespan of approximately 60 years, and then you have this big, nuclear reactor full of radioactive materials that's just sitting there, and they can't really do much with it. So look, there's massive problems with them as well. Now, I'm just going to take you a little bit further. These reactors are fission reactors, okay? So the kind of reaction that's going on in all of these nuclear power plants are what's called nuclear fission. And for nuclear fission, you need uranium, that's the fuel, enriched uranium a lot of the time. And fission is the splitting up of an atom. So they take an atom and they split it, and there's a release of energy when you do that, which is obviously what they then use to provide some of the electrical energy that we need on Earth. But there is another nuclear reaction called a fusion reaction, where instead of splitting the atom, you bring it together. And the fuel for that is not uranium, so it's not something that when you mine you get lung cancer. The fuel for that is actually called deuterium, and it's found in our oceans. So it would be much easier to mine. Um, there's less of a chance of this kind of runaway explosive reaction that happened in Chernobyl or Fukushima with a fusion reactor. Um, so there's massive funds all over the world going into trying to develop fusion. The problem with it at the moment is that in order to do it, so if you want to force um, two atoms together, we talked about atoms a couple of weeks ago. If you want to force two atoms together, you're what you're forcing together are the nucleus, the nuclei, and if you remember, in the nucleus there's protons and neutrons. So a nucleus is positively charged. So what you're trying to do is you're trying to drive together two positive charges, and positive charges don't want to be together. So in order to overcome those forces, because they want to repel. So I don't know, have you ever taken a magnet and tried to force the same ends together and they just don't want to go? It's kind of like that, except, you know, on a massive scale. Those nuclei do not want to go together. So in order to get them to go together, they have to provide a huge amounts of energy. Like I think it's 800 Kelvin or something, like massive amounts of energy to drive the two bits, the two nuclei together. So essentially, at the moment, to start a fusion reaction is costing more money than the amount of energy that it's producing. So it's like they can do it, they can do fusion. The problem is it is costing a fortune. So the whole point, obviously we talked about it up above, is that you need to produce forms of energy that are efficient, cost effective. You know, you have to be able to, it can't cost you, you know, it can't cost more to generate the reaction than the amount of money that is going to generate in producing electrical energy. Like that doesn't make any sense. It's not a good business model. But if they can do it, you're essentially talking about a form of nuclear energy that has all of these advantages without the disadvantages. So there's a huge drive on for perfecting and making more efficient nuclear fusion. All right, so that's it. And actually, that's the chapter. Yeah, it is. So I'll give you your homework. All right, have a good day.